So are you ready for an eclipse? I want to start off with a story. I was vacationing in Boulder, Colorado, where I went to school, where my wife grew up, several years ago, and there was this conference. It's called a Teton Conference. And it was down in the Museum of Natural History in Denver, and it was very engaging people, lots of ideas floating around. But one video that's particularly relevant for today is they had a video about a total solar eclipse. And what they had is they had a bunch of Vikings in a longboat out on the North Atlantic, and the sea is kicking them around all over the place, the clouds are cloudy and so on, and they're rowing across the North Atlantic. Okay? And so they're making their way, and the guy out in front of the boat suddenly goes, you know. For some reason, they didn't speak Danish or anything like that. I don't know why. And all the rowers go, oh. And then we see a picture of the sun and some monsters eating the sun, right? A solar eclipse is occurring. So what do Vikings do? They grabbed their swords and shields and started banging the crap out of their shields with their swords, hoping to scare the monster away. And the monster keeps making the sun darker and darker, and they get all frantic and berserk, which is a good word for this right now, right? Banging on their swords, and they're just totally upset, and finally the sun eclipses, and they're just going crazy, and then totality ends, and the sun peaks back around. And the crescendo dies away of their beating against the swords and shields and so on, and they put them down, and they grab their oars, and continue to make their way across the North Atlantic. Give me a break. Think of it. You got some guys who are able to build a boat that would withstand the rigors of the North Atlantic, right? They could navigate by the stars like they hadn't been watching the moon the last few nights, right? As a matter of fact, if you go outside tonight, you'll see a moon. Not quite tonight, tomorrow night. The moon going through its phases, right? So I stood up and essentially said that to the audience, and they all looked at me like, oh my goodness, what is this? And the guy in the back leans over to a friend and says, I think we've got a scientist in the crowd. All right, I made that part up, but in any event, is for although solar eclipses are marvelous, we tend to put a special innuendo on them that they're not understood by people before us. And of course, that's not true at all. People before us could see the night sky and see what was coming on. So I want to give you an example of that. These are August 18, 19, and 20 positions of the moon looking east from where we live, 40 degrees or so north latitude. And you can see night after night, the moon was working its way night after night towards what? What's down here below the horizon just before sunrise? The sun. Yeah, it's on a collision course with the sun. And these guys would have seen that without a doubt and would have inferred, by golly, this moon might well be hitting the sun or going in front of the sun, but certainly not a surprise. Furthermore, if we pay a little attention, and this is something you want to do, so let's hope it's not cloudy today, but you'll definitely have an opportunity in a day or two to get out at sunset, right? Like I've drawn here, look off towards the west and you'll see a crescent moon, right? The moon having just slid past the sun. Today it's going to line up with the sun, but night after night you're going to see, right? If you go out at the same time, the moon working its way night after night towards the east. Now make no doubt about it, the daily motion will make it set in the west, but if you go out at the same time every night, you'll see this easterly motion. About 7 days later, a quarter of the cycle, you'll get a new moon, first quarter moon through the gibbous phases, and then finally, 2 weeks from now, we'll have a full moon rising off in the west when the sun is setting. And just to continue this, I show 12 hours later, right, sunrise. So now we've got the sun in the east, that full moon will be setting in the west. Have you ever seen a setting full moon when you get up in the morning, off in the west? Isn't that pretty? Yeah, I love it. One of my favorite things. Me and dogs, my 3 dogs, we love to go out and look at the moon like that. Of course, they're sniffing the ground. What do they know? Okay. But again, through this cycle, this monthly cycle, there's a regular pattern up there, and I can't stress that enough. It's not chaos up there. There's a pattern, and patterns are telling you what the heck is going on. And here's your chance now. With this eclipse, you can do more than the eclipse. You can follow the moon for the next month and see this pattern. So please try to do that. All right, well, this is the standard diagram of what's going to happen today. All right, we're going to have a total solar eclipse. It occurs during a new moon. We've got the sun, we got the moon between the earth and the sun. The shadow of the moon falls on the earth. For us today, that little black spot will be about 60 or 70 miles in diameter. It's going to move because the Earth is spinning on its axis and the moon is going around the planet as well. So we got it screaming in from Oregon, going to clip across here, northeast Kansas, and an hour or so later go out in South Carolina. Let's not forget there are also lunar eclipses too, and they're closely associated, as I'm going to show you, to the solar eclipses. So this is again an alignment of the three bodies, but now of course the moon is behind the Earth and the shadow of the Earth falls on the moon. You know, just paying attention to this, who gets to see a lunar eclipse? What part of the globe do you have to be on to see a lunar eclipse? The back side, right? The night side, but the whole night side gets to see it, right? So whereas with our solar eclipse, South America isn't going to get to see this, right? So it's more localized with solar eclipses. And that's why lunar eclipses seem to be more common. But in fact, they're not. Okay, well, there's a picture of a lunar eclipse just for completeness. And here's our month of August, right? Here we are, right there, the dark of the moon, right? Yeah, and a few weeks before that, right, back on the 8th or 9th or so, we had a full moon. All right. Now, I was trying to show you that with a month, you could look for periodic patterns in the motion of the moon, watching its phases, okay? And that's the foundation to science, systematic and quantitative observations. Here's another series of systematic and quantitative observations, but they're over a 2-decade span. So I went to the place we all go for information, Google, right? And I found all the eclipses that were visible in Manhattan, Kansas for 60 up to 1979. And you can see there are a lot of lunar eclipses, some of them were partial. Every once in a while there was a partial solar eclipse. So here's a record of what's going on. Now, is there any pattern in this record? That's the question. And scientists just love to draw graphs, right? And actually, when you think about it, we all love to draw pictures and things. We're picture-oriented, right? We can see more in a picture's worth 1,000 words, right? Trivial as a statement. So let's take these data and let's make a graph out of them. And I'm going to make a graph that looks like this. You can see I've put the year over here, 1960, 1961, and so on. And then I'm going to put the month across here, January, February, March, right over to December. So if there was a lunar eclipse, say in March of 62, I'm going to put an L in the March 62 box. You got me? Okay, now let's take those data and see what happens, okay? Isn't that cool? I mean, what warms a scientist's heart more than a pattern unfolding? There's a pattern there, right? Look at that. Fantastic. A pattern unfolds. Let's add the solar eclipses. Look at that. The solar eclipses line up with the lunar eclipses. Matter of fact, take a close look. Lunar, solar, solar, lunar, solar, lunar. Now there's some off by themselves. The pattern isn't perfect. So what do you think's going on when we have a lunar and a solar eclipse right next to each other like that on this chart?
They're 2 weeks apart?
Bingo, 2 weeks apart from new moon to full moon, or maybe from full moon to new moon, yeah. Matter of fact, when they come in pairs like that, it's called a season of eclipse. You didn't know that, did you? Neither did I before I learned all this stuff, all right? So absolutely, there's a pattern here. Now, let's expand this to the worldwide point of view. The point I'm trying to make is you don't have to necessarily be communicating with everybody around the world to find these things out. You could imagine we did this 4,000 years ago, for instance, right? This could have been done 4,000 years ago in Manhattan, Kansas, and we would have seen these patterns, correct? That's the important thing. It's not some esoteric science that requires computers or stuff like this. This is science at its foundation. All right. Yeah, so let's see. I'm going to throw in worldwide, so I got a lot of black solar indications too. And now look at this. Who outnumbers whom, right? The lunars or the solars? It's pretty equal, isn't it? And you thought solar eclipses were rare, didn't you? All right. So, we may not understand entirely what's going on. We're going to come up with theories for that, and we won't today. I'll just tell you the answer. But could you predict the future?
No.
Oh. We have a doubter in the crowd. So, suppose it's 1980. When do you think there might be an eclipse? You see that? Yeah, she agreed. Yeah, January or February. A good possibility. All right, why not every new moon and full moon? The reason is because the orbits are tipped a little bit. So this is a very schematic diagram. The orbit of the Earth, and notice they got the sun moving, so this is pre-Copernicus, I suppose. It's very hard to find pre-Copernican PowerPoints, and I defy you to say pre-Copernican PowerPoints 3 times in a row. Nevertheless, there is a tip. It's about 5 degrees. I'm going to tell you in a little bit that the sun and the moon both appear to be about 1/2 degree. So that's about a 10-to-1 ratio. So you got to line up pretty well. Here's another diagram that maybe will help that. But you can see that very often they're not in the same plane, so the shadows can't fall on each other. But when we're along a node, that can happen. And there's 2 nodes in the orbit. And how long is the orbit for the Earth? A year. And what's half of a year? Let's see, 1 divided by 2 is 6 months. How did I get 6 out of that? In any event, remember the pattern. They were about 6 months apart. So that's what's happening. We line up on the nodes every once in a while, and then there's a good chance of getting both solars and lunar eclipses. All right, so let's do a little thing here. I've brought a baseball, okay? So if the Earth was a baseball, okay, and the moon was would be a marble. So I want these 2 young ladies, sort of young, to stand up and hold those over their heads. Okay, so that would be the relative sizes of the Earth and the moon. But then how far apart would they be? I guess I need my clicker. Where did I put my clicker? Oh my goodness, I'm lost. There it is. As a matter of fact, the sun on this scale would be 25 feet in diameter. No, just cool it, okay. So, with this scale, how far apart would they be? Well, they'd be 8 feet apart. So scooch on over here a little bit, hold it up. There you go, 8 feet apart. Now you can see how hard it is to get the shadows to line up, right, on this sort of scale. Now the sun is going to be 1/2 mile away. It's 25 feet in diameter. What the heck, it's a pickup truck, okay? So try to imagine a pickup truck out there somewhere, 1/2 mile away. And of course, I guess if I put the pickup over here, matter of fact, that's the wrong one. I have to put the pickup over here, right? So the light will come shining in. Here it comes at the speed of light, boom, pow, like that, right? And actually, that was about the right amount of time, as a matter of fact. So, to cast, keep your arms up, okay. Did you take a bath this morning? No. All right, where was I? Oh, but let's get serious. Think about it. The sun's over there 1/2 mile away, moon, Earth, Highland, Kansas. And what else is there in between? Absolutely nothing. Okay. Such are the scales of our universe, and that's only the beginning. Okay, thanks a lot. Give these girls a hand. Okay, let's see what's next. Here's a remarkable fact, too. I was mentioning that both the Earth and the Moon appear to be the same size. I said that wrong. Both the Earth and... I'm going to do this. I really can do this. Both the Moon and the Sun appear to be the same size, but of course the Sun is a lot bigger, but it's further away. And so if you do a little math, okay, and there's only one person I know in the audience who likes to do math. He's sitting back there somewhere. If you take the diameter of the Sun and divide it by its distance, and then if you also take the diameter of the Moon and divide it by its distance, son of a gun, you get the same number. It's the same ratio, okay? So the ratio is the same. Isn't this cool? Yeah, I mean, really. Don't you wish you could go back to school and study math and science again? Truly. Okay. So, and it works out to be about 1/2 degree. And so they appear to be, the apparent angular size is the same. And that means when the Moon goes in front of the Sun during an eclipse, it's a perfect match. So we really got lucky that way. So I took a vacation on Mars and I took these pictures. And you can see it doesn't happen on Mars. Here's one of the Martian moons, which when I grew up was hollow and filled with Martians. But it never, oh, the mystique we had then, yes. Okay, but you can see it doesn't match anywhere else in the solar system. All right, well, let's just throw some examples at you. This idea of the commonality of solar eclipses. I've got, here's our today's solar eclipse, August 21. Look, right? When we had a new moon, a full moon just 2 weeks ago, there was a partial lunar eclipse visible in Europe. And now look back in February, there's another doublet, right? And how many months between February and August? 6 months, you see that? And it goes in the future too. Here's another doublet and another doublet. All of these spaced by 2 weeks, new to full moon, and then of course to the next season of eclipses with regard to a 6 month, actually it's more like 5.5 month interval. Okay, well, if it's cloudy today, we do have an eclipse coming up in 7 years. And it will sweep in across Mexico, across Texas. The closest to us in Kansas will be southern Illinois, eastern Missouri. And what's really rather interesting is it's going to sweep across the populated northeast coast. I talked to my brother-in-law last night who lives in Denver, and he just gave up on the idea of driving up I-25 to Wyoming because it's going to be like a parking lot. And of course, that's not the northeast coast. So I have a feeling a lot that we're going to learn today about gridlock, or the lack of it for us, fortunately, but perhaps across the country will be very useful to know in 7 years. Here's the next reasonably placed solar eclipse that will be total. So if, again, you're disappointed today, if we walk outside and it's thunder and lightning, make your reservations for Santiago, Chile, right there. Here is the next century of eclipse paths for North America. And there's our eclipse today. There's the eclipse 7 years from now. You can see there's southern Illinois or so. There's one in 2045. I hope I make that. But nevertheless, there's a series of them that young people might well be able to appreciate. All right, so here's our eclipse. And it came in, remember, it's like a 60-mile in diameter dot of blackness sweeping across the country. For us, first contact is going to be 40 minutes after 11, which means you're all going to abandon me in about 10 minutes. All right, and I'm going to try to finish in that time. Let's get a little more close-up view. Here we are in Highland. If that's my broker, tell him to move those shares of Merck over to AT&T for me. Yeah, so we're going to have first contact at 11:40. We're going to have beginning of totality at about 5.5 minutes after 1 Central Daylight Time. Now, observationally, these pictures were taken with a mostly clear sky, so I'm not sure what to expect. But as totality approaches, even before this 15 seconds or so before totality, perhaps a minute or two before totality, you want to be watching the ground, because one of the more unusual effects that you get during totality is a phenomenon called shadow bands, which is sort of a fluctuation of light and dark on the surface of the Earth. It's analogous to the fluctuations you see at the bottom of a swimming pool when it's a nice sunny day fluctuating around. So look for that. Very near totality, 15 seconds or so before, you may get the diamond ring effect. So you might notice a bit of a ring here, but there's a very brilliant nature to this too. You still want to have your solar glasses on now, so you don't want to hurt yourself. I think I have another picture of the diamond ring effect, which looks more like a diamond ring. You can see the name, okay? A few seconds later, perhaps 5 seconds before totality, that single gem might break up into a few gems, so-called Bailey's beads. Still, you have to have your glasses on during this, all right? What I find remarkable about this is due to the fact that the lunar surface, of course, has mountains and valleys. And so that's showing the edge of the moon. And where the light is brightest, the light has skimmed through a Martian valley, which is kind of neat to think about. You know, imagine being a photon zipping through the valleys of the moon with mountains on each side of you. Did I say Martian? Moon Martian, you know. Well, it's that vacation I took. It's still stuck. Okay, I'm sorry. I meant to say lunar valleys. Let's see, what else do I have? Oh, and then finally totality. So I have never seen a total solar eclipse. So you might say, what the heck do I know, right? I've read up on this stuff, and I've dreamed about seeing such a thing since I was a kid making telescopes. In any event, I can imagine that we'll be out with our solar glasses on. We'll see these diamond rings and Bailey's beads, and as soon as everything goes black, I guess that's when we take off our solar glasses, okay? So when we do, perhaps the most distinctive thing we'll see is this solar corona, which is apparently a gossamer white type of a color, and it might even shimmer ever so slightly. Well, here's a mark. We probably won't see it with this detail, but it does give you some idea of what's going on in the solar corona. Very strong magnetic field effects, as photographed by Mr. Eclipse, Fred Espenak. Another thing that you might get during totality is a view of the chromosphere, which is just underneath the corona. So this is right along the edge, or the limb of the sun. Notice these flares popping up. The red is due to the fact you have gaseous hydrogen that's very hot, and it will emit a red light, the so-called hydrogen alpha line. These prominences are solar explosions on the surface, and the size of the Earth is less than that circle inside the A right there. So you can imagine how big these explosions are on this scale. The other thing to do during totality, and you're going to have 2.5 minutes, you want to do a lot of things, is many of the stars will come out. So this will be our sky. Here's west and east. So it'll be near zenith, which is straight up. So it would be right up there. And then towards the west, I'm sure you'll be able to say Venus, and many of you who've been up before dawn have probably seen Venus in the morning sky. So here's the sun. Venus should be over here, quite bright. Off in the other direction will be Jupiter, which should be visible. There's a chance you might be able to pick up Orion's belt, and that would be off on the western horizon. So look for that as well. Now, things not to do. Okay, use your solar glasses and only use your solar glasses. Now here's a guy using his solar glasses, but he's looking through a telescope. Okay, so this is a KU professor. And it didn't work, okay? He still fumbles around Lawrence, Kansas like this, okay? Here's another KU professor, the stack of 27 sunglasses, right? Won't work, won't work. Don't do anything like that. Photographic negatives won't work. They're not dark enough, et cetera, et cetera. Smoked glass, which is an archaic way of making glass dark. What you want to do, of course, is use the solar glasses. I think we still have some. I know I still have about 50 of them. Welder's glasses work. They're fine in number 14. I've got a telescope set up outside with a solar filter on its aperture, and I hope we'll be able to use that. And you can also use eyepiece projection from the back of a telescope. But of course, if you're doing that, don't look through the telescope because that light is very, very bright and it will harm your eyes. Here's one that works for all of us. It's the so-called Pinhole Camera. And I'm going to move to the next slide. It doesn't have to be a pinhole. It just has to be a sheet of cardboard or paper that you poke a hole through, perhaps with a pencil or a pen. Pen is too small, but a pen or a pencil works very well. Have it fall on a smooth surface. Let the light go through. The sun's shining like this, falling, and you get an image. Now, I have a better picture. You can do this by hand. I've done this just a few days ago with a bunch of grade school kids in Junction City, Kansas. We all went outside and we just made a little hole, right? And stand out in the and there it is, by golly. Now, when you do this on a normal day, you get a little round circle and you say to yourself, oh, it's a little round circle because my hand has a little round hole in it. No, 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 no. That really is an image of the sun. Another thing you can do is kind of pinch, see what I'm doing here? Squeezing down with the fingers, both horizontally and directionally. Stand like that, and you'll get a pinhole camera too. And when it's getting eclipsed, it'll be a little crescent like that. Matter of fact, that's about 98% eclipsed. It was what it looks like to me. So you can do all those sorts of things if the sun's shining. And don't miss the chance to stand under a tree. So I'm sure you've all walked under trees in your life before, and you've seen all the little doppels on the ground, little round circles and stuff. Those little round circles are because in the myriad of leaves above you, the light's filtering through and as if it was a pinhole, and you're getting little round images of the sun. And today you'll prove that because there'll be crescent suns because they're getting eclipsed. Let's go see it. Any questions?